Hey everyone, today we'll start with bit manipulation, and it's really important topic. Like if you are doing competitive programming, so this is kind of like a base for that, and it's really an interesting topic. It makes your code more optimized with respect to speed and all. We'll see what all things we have here. So first of all, if you are in college right now, you might know about binary numbers and binary to decimal conversions, right? But even still, I would like to basically start with first part, which is binary number conversion, basically, right? Just so we all are in same page, right? So that's why I would like to start with the binary number conversion, right? So let's take one number as 7, right? So 7 we have, it is in decimal form, so we denote it like this, in this way, right? Now what will be its decimal form? So there are two ways to find, basically, to uh, make this into decimal form, right? So first way is you can easily divide it with 2, right? uh, so let's say 2, and remainder you can write here. So 2 threes are 6, right? So you can say 2 3, and remainder will be here 1. Now again 2 ones are 2, remainder will be here, right? And yeah, that's done. And 1 1. So in binary conversion we will go from here to here, right? From like in this way, and hence the binary conversion would be 0 1 1 1. Just remember that we basically uh, like our conversion is like we always write in four let in ones, right? Ones and zeros, binary, four binary digit bit, 4-bit way, and it will be denoted like this, right? There's another way of doing this. Basically, these four bits, basically, you can also say that this first bit corresponds to 2 to power 0. This one corresponds to 2 to power 1, 2 to power 2, and 2 to power 3, and this goes on and on. Like as you know that if you store any number in int, the computer stores it in form of decimal form, because computer always works with binary digits, right? Like if you say, okay, just one quick thing. Like let's say that if you type here int a is equal to 7, let's say, right? So computer won't basically set this as 7. It won't store it as 7. It will first convert it into binary digit, which will be in 32 bits, because int is in 32 bits. So 32 bits means it will be start from 0 0 0 till last, like 32 28 times, and last four digits will be like this is how it will be stored in a memory by computer, right? So please remember. But I won't be writing all the 32 bits right now. I will be just we will be just playing with last four bits. Got it? So that's the context behind this. So it is calculated in this way. So 2 to power 0, which is 1, 2 to power 1 2, 2 to power 4, and this is 8, right? So if you want to make 7 using these, which bits you will set, right? So 8, basically you can start with 1, right? So 4 5 6 7, so first three digits you can say 1, and this will be 0. So that's how you can also get, you can basically just remember this rule. I mean, not I mean just uh, this way, so that you can just directly write it. Instead of dividing it, you can directly write all the bits of, you can basically convert any uh, decimal to binary, right? So this is binary. I guess I said this is as a decimal, right? No, so decimal to binary. Let me also write this. Uh, First part would be decimal to binary conversion, right? And I guess it's quite easy if you do the vice versa as well, right? So let's take one more example here, right? Let's say you want to uh, convert 13, right? You want to convert 13 base 10, right? Which denotes that it is a decimal number. You have to convert it to binary number, right? So how will you do that? Easy. You can just 8421. So for getting 13, what you can basically add 8 9 10, or 11, no. So 8, 9, 10, 11, 12, 13. So you can do this 1 1 0 1. Got it? Very easy. So 13 you can do this. Right. Now let's do second part. Let's jump into second part, which is binary to decimal. Right. So let's just stick with one example only, so that this is just basics. This is not even, we have not even started. So I just want to stick with one example so that you don't get much deep into this. Right. So let's say that we are given 101, which is basically 13, right? But you need to calculate it in certain way so that we get decimal, right? So how will you do that? It's easy. You can just, as I told you, this is just 8421, right? And you can just check if each bit, if any bit is 1, then just plus. If it's not, then make it 0 and then add, and you will get 13 as 2, right? Now how you can code this out, right? So important is how you can code this out. We will also write that, but in questions generally you don't need to code this thing, which I will be explaining later on. But yeah, still, if you want to see the code, you can see how we can make this. So let's say I'm making 1101 as a string, right? So string, convert to what, decimal, right? Convert to no, sorry, convert to binary, right? And I will be giving one integer x, right? So how you can convert it? Let's say that we I'm storing result as a string, right? There's a string I have stored, uh, and I'm just writing basically pseudocode, right? So please don't mind it. If n is not equal to 1, right, we need to give that case. We can say that if n is divisible, basically if n is divisible than 1, right, just make your string, basically add in your res string 1. Again, I'm treating the binary digits as string here, right? And else, if this happens, else what you should do, else what you should do, you can just make res plus 0 as 0, right? That's the case here. And you can also, uh, as you are doing this, you can also make your n, basically n is equal to n by 2, right? You can, as the basically as you are going backwards, right, you will have to, as you're dividing, you have to make it big, you need to break this, right? So n by 2, n by 2, n by 2, right? Now, uh, yeah, so you will get the result. Basically, you are dividing it, right? You have to return the result in a reverse form, right? So you need to, after that, you will get some result. You need to reverse it as well, right? So you need to reverse. You can make one reverse function. It's not that much complex, and then just return res. That's all. This is the basic code. Basically, here we are just dividing it by 2 and we are making the number smaller, right? And this is how it is getting. So I'm treating here binary as a string here, right? So that's the case. And what will be the space complexity, time complexity of this? The TC would be easy. It will be log of 2 power n, right? Because we are just halving the result, right? And space complexity would be also, I guess, log of 2n, right? Because we are not using any extra space, we are just dealing with this, right? So log of 2n, right? Now let's go ahead and we can also write code for the reverse one, right? Let me write that as well, right? So again, I need to basically, I'm writing convert to decimal, convert to decimal. If I have given x string, right? So I can just say int l length is equal to x dot length. First I need to get the length, right? Yeah, and then for, I can just go with for I is equal to length minus 1, go till 0, right? I'm not focusing on the syntax for now, just see the logic behind this. So if n of I, basically if m and I is equal to 1, we have to convert it into decimal, right? We need to convert it to decimal. So if n is equal to 1, then you can just make your num plus p2, right? uh, the logic behind here is that basically, let me just make it for you as well. So see, so we need to, what was happening in our first uh, thing, like 1 2 4, it goes like this, right? So we need to basically go in this way. So we are basically multiplying it by 2 2 2, right? The thing which I told you here in this way, 2 0 2 1 2 2 2 3, right? We are going in that way. So hence I'm just making uh multiplying it by 2, right? You can, yeah, so I'm just making that, and then after that, after you get the num, you can just make p2 into 2, because as the logic says, and then you can just return the num. Got it? There's nothing much here. So these two are the convert to binary and decimal, right? You can, I can highlight this. So this is what the code was, and you won't be using this much code. I just explained this for your own logic of how bits are working here, right? And for this the time complexity and space complexity, this would be O of length, because as the length, it depends on the length completely, right? And the space complexity would be 1, because we are not using any extra space here, right? So that's the case. And one thing you need to basically know, as I told you, like, let me just write that as well. So as I told you earlier as well, that if you store a number, basically if you write x is equal to 13, right? If you store an integer, it is converted first to decimal, right? uh, I mean, it is first converted to binary, my bad, let me correct that. It is first converted to binary, right? If you are storing that number, it is first converted to binary 1101, and then it gets stored. And also, if you're writing int, which is 32 bits, right? So it gets actually stored in this way, 0 0 0 28 times, and at the end it will be like this. So this is stored in the memory, right? So yeah, and again, if you want to get the x, then it is again converted back to the decimal by the computer, and then you will get that number, right? So that's it. And now one more concept I need to basically discuss with you all. So the concept is, I guess, even if you have maybe learned this in your college. So concept is first one's complement and two's complement, right? So let's see what is this. If you are not clear with this, then you might get stuck later on, right? That's why I want to clear the basics first, right? So first complement, one's complement, let's say that we are given 13, right? 13. So if you want to find one's complement of this is 10. So first of all, you need to convert it to the binary number, which is 101, right? And then one's complement basically means you need to make all the, basically you need to reverse all the bits, right? You need to toggle all the bits. So let's say 1 will become 0 0 and 1, and this will become 0. So you have done one's complement here, right? One's complement basically means you are just toggling all the bits, right? Just remember that, right? Now coming to two's complement, right? So there are two steps here. First step would be to do one's complement. Second step would be to add one. Yes, add one. Let's see how. Let's see how. Let's take example of 13 again, right? So 13, if you want to do 2's complement of 13, right? How will you do it? It's easy. First you will, as it said, like as we said, we need to first make it one's complement, right? So first of all, we will do 1101, right? One's complement you can do, which will be what? It will be 0010, right? And then you need to add one. Add one. How you can add one, basically, it's the logic is not complex. Like 1 plus 0 is 1, 1 0 0. This is what you will get as 2's complement. So the output of 1's complement is this. Output of 2's complement is this, right? So please remember, please just understand this whole concept right here. We'll be using 1's complement a lot, right? Now quickly coming to operators. Again, this we are just covering the basics here, operators, which is really important, right? Because I want you all to be on same page first, right? And I'm pretty sure even you have done this in your college, right? So first would be the AND operator, right? AND operator, which basically means all true. All true means that you will get the output as true, and all and one false. One false would mean that you'll get false. No matter what, you'll get false. If any one is the um, false. So let's also write example side by side here. Right. Now let me make it a little bit better. Operators, and this would be, yeah. So let's say AND operator, right? AND operator. We can make it like let's say n is equal to given n is equal to 13, and we need to basically AND 7, right? 13 and 7. So 13 is 1 1 0 1. 7 is what? 0 1 1 1. Right? You need to basically AND operator. You need to AND it. What will be the AND of this? So 1 1 all true, which means true. 1 0 1 false, there's one false. 0 means false and 1 means true, by the way, right? So 1 false, which means false. 1 1 1 1 0 1. So this will be the output. Now got the logic? Simple logic, it's there. Now coming to the second operator, which is let me just copy paste this only, and I will edit it. Second operator is the OR operator, right? And this is also all true. Basically here it is one true means true, and all false, here all false means it is false, right? So it's kind of like a plus operator, right? And this is kind of like multiplication operator. If you see, like if there's a zero, you will get output zero, right? And here it will be something else. Let's see what will be. So again, if I do 1 1 0 1 and 0 1 1 1, right? If I do OR operator is represented by this single line, right? So OR operator 1 1, which will be 1 easily. 1 0, here it will be 1, right? Because 1 true is true. If there's 1 exist, so there is 1. So 1, this will also be 1. So yeah, you can see here. Uh, it basically means that if there's exist one true, it will make it true. So it's like plus operator, right? So that's thing. Now coming to the third operator, which is the XOR. So this kind of interesting here, and many people are kind of confused. Like even like when I was in my college, I was pursuing electronics, and even I used to get confused with XOR operator. So I will make just it easy for you. Number of ones, right? If the number of ones is odd, then your answer would be 1, right? And if your number of ones, if number number of ones is even, then your answer would be 0. So please make a note of it. Many people get confused between these two. So please remember, as you practice, you will get that. So let's say again, taking an example here. So let's say 1 1 0 1 and 0 1 1 1, and you have this wait, you have this XOR operator is represented by this, right? So if you do 1 1, number of ones, if it is odd, then 1, right? So number of ones is what? How much? It is 2, right? So it will be 0. Got it? 0. Once number of ones is odd, only there is only 1 1, so it is odd. Number of times the 1 is occurring is odd, so it will be 1. Again 2, so 0. This will be 1. So this is what you will get, right? And yeah, so you can see the pattern now, right? Now coming to one of the most important operations in this bit manipulation, right? So first we'll be discussing with the shift operators, right? uh, so first I will be developing right shift operator. Let me this it is basically it is like this. It is called right shift operators, and you will be using these operators a lot, and most of the questions, right shift, left shift, a lot, right? So let's first understand what exactly is right shift operator, right? So let's say n is equal to 13, right? We have n is equal to 13, and it is right shifted by 1. What does this mean? Let's see. So like as we have entered, as we know that 13 will be stored in binary digits in computer, right? So it will start from 0 0 and it will go to 28, and it will be like 0. How was 13 represented? 1 1 0 1, right? So it will be like in this way, right? And this will also be 0 here, right? Because there are 32 bits here, right? Now if you have shifting to 1, you are shifting to 1 this side, you are right shifting to one side else, right? So what will this mean? Basically this will go here, which means that it will be discarded. This will move here, this will move one step to right, this will move here, this will move here, right? So let's make the right shifted. So yeah, so with this place, this will come here, 0 will come here, like here it will go here, 1 will come here, this one will come here, this will come 0, and da 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 da, this will also be 0 0. So this will be the new one. So this will become, which number this will become? This will become 6, right? Because 2 to power 0, there's nothing. 2 to power 1, 1, 2 to power 2, 4 plus 2, 6. So 13, if you have shifted 9, if you are shifting one right shift operation to 13, it will give you 16. Sorry, fuck, 6, it will give you 6, only 6. Got it? So yeah, you'll get 6 here. So please mind that. You can also do one more operation. Let's say you are doing n is equal to 13 and you are right shifting it by 2. You are right shifting it by 2. Let's see how it will be right shifted by 2. Right. Uh, yeah. So 0 0 0 again. I will draw the, I will make this as 1 1 0 1. Right. So uh, it is shifting by 2, right? How will this get shifted? Basically here now you can just directly do that, this and this will get discarded basically, right? Because we are basically moving them outside, out of the scope, right? You can see that. So what will be the new number? The new number will be 0 0 0, right? It will come, it will just fill up the zeros, right? And this will be gone, and this it will be like this. Got it? And this, which number will this become? This will become as 3, right? You can see if you shift, right shift 13 by 2 places, you will get 3. One thing to note here, because we will draw one conclusion with all this, right? Okay, so you can see the pattern right here. 6, if you right shift by 1, it will go give you 6. If you right shift by 2, it will give you 3, right? And if you do this, if you basically make 13 right shift by 4, basically all 4 bits will be gone, so this will make you 0, give you 0 directly. You can just see it's living logical, right? Hence now seeing the whole pattern, we can conclude one thing, right? We can conclude one thing, and it's really really important, right? That, let me write it that in red, that n, whatever we shift to right by k, this basically means that x, any number which is given, is getting multiplied by 2 to power k, right? We will prove this as well, how this got, how this we got. But please remember this, this is really important, really important. How we got this, we can also confirm this here by seeing this, right? So let's say that 13, we had 13, right? And if it was shifted by, if 13 was shifted by uh, uh, 2 to power 1, right? What was, if it was shifted by 1, what was it given? 6, it was giving 6, right? So what will be the answer of this? 2 6 are 12, so it will be 6 only, right? Because we are not considering decimals here in this thing, right? And if you also make, this will be actually, this will be x actually. Yeah, now it is fine. Now if you do 2 to power, let's say if you shift by 2, which is 13 by 4, what will it give? Like when it is shifted by 2, when 13 was shifted by 2, it was giving us 3. Let's see, will we get that? 4 threes are 12. So we will also get 3 here. So you can see the pattern now, right? So please remember, this is what we concluded. Really important. If you want to basically divide any number, you can just shift it by k. I mean, as in according to the need, right? So this is one conclusion which we got, and yeah, you can also prove this like mathematically. You can just prove this as well. I can show you that, but I guess that's not much of the priority right now. So we'll be moving ahead. But you can obviously you can just get you can just search this proof. So um, I can give you that as your homework. Yeah. So your homework will be to just prove this, right? Prove maths, mathematically prove this, right? Because it's just out of scope right now, right? But yeah, now uh, now coming to one more point, like how CPU stores positive and negative integers, right? So how how computer stores positive and negative numbers, integers, whatever. So this is what our concern right now is. We want to learn how this happens. Let's say again I am taking x. Let's say we want to store plus 13, right? Plus 13 or 13, just 13, which means plus only. Yeah, right. Uh, how is this stored? So as I told you that this is stored in 32 bits, right? So first, second, third, till 32 28 bits. After 28 bits you will get 1101, right? And all these numbers are stored as 0 because there's nothing value, and but there's one bit which is like the first bit is reserved for like the reserved in the computer for just checking that if the number is positive or not, and if it is 0 it means that it is positive. So you can just say that here, you can just say that first bit first bit is always reserved for telling, for deciding if number is positive or negative, right? You can draw this one conclusion here, right? So that's the case. So if it is plus, the first bit will be 0, right? And if it is 1, the first bit would be mine, like if it is basically 0 means positive, and if it first bit is 1, then it means it is negative, right? So that's the whole point. Now one more thing you need to see, you need to basically know, let's say that this is the case for x is equal to plus 13, right? Now what if I wrote x is equal to minus 13? How computer stores this number, we will see. So first basically when we enter this minus 13, first it converts 13, just 13 to binary number, which is basically 0 0. It first makes it 0, right? Let's see, it happens in step to step. So first it will make this, and then whenever number is stored in minus, it will do the 2's complement of this. Got it? 2's complement. So you can, one more note you can write here is that whenever whenever number is stored in negative, computer performs 2's complement, right? So we will be doing 2's complement of 13 first, right? 13. So 2's complement of 13, how would we? First we will be uh, the 2's complement steps were two steps. First we will be doing 1's complement. 1's complement means toggling all the bits. So it will be 1 1 1, right? 1 1 1 1 1, and last, and these bits would be 0 0 1 0. This will be the first one complement, and then you need to what? You need to add 1 here, right? For 2's complement. So if you add 1, what you will get? What you will get? you will get basically, if you add 1 here, you'll get 1 0 plus 1 plus 0 plus 1, which is 1 1 0 0, and this all will be 1 1 1 filled with 1 1 1, right? This is what you got, and this is how it is stored. So, and if you see here, the first bit is 1, which means that it is minus, and this is how minus 13 is stored. And you can say that this means this number means what, minus, uh, this is stored in minus 6, right? Wait, 2 0 2 1, so 2 plus 1 3, it is stored in minus 3 kind of way, right? But this is how it is stored, right? So also, you can also, one more thing to note, if you are well familiar with the CPP, if you are basically using the CPP language, you can say, I can give you one fact, longest number, about the longest number. So seeing the thing which we saw, like how the numbers are stored, you can, what can be the longest number that can be stored in in these 32-bit number? What can be the one? It can be easy. It can be like, if the first number, like the longest number or the largest number, right? So first should be the 0, because we need the largest number. Else everything can be 1, right? Everything can be 1. This would be the longest number, right? uh, and what is the value of this? You can say 2 to power 30 plus 2 to power, you need to do math some, right? 2 to power what, 29 till 2 to power 0. This will be the number, the value number. Or you can just make it as 2 to power 31, just using maths, minus 1. This, it equates to this. And you know what, for the fact, this 2 to power 31 minus 1, this is what is the, wait, let me, yeah, let me write that, because it's really important. Good. Int max. Yes, this is what int max is. Whenever you write int max in the question, right, you used to write in, like, when you are assuming that the number is max. So this is what the value of int max is basically, right? So it's really, I thought it's really interesting thing to know. That's why I was telling you, right? It's good to know this term, right? And also, if you now consider what can be the smallest number which can be stored here. What can be the smallest number? Let's see. Smallest number. Smallest number. This can be, so to get the smallest number, what can we do? We can first make the set bit as 1, because we need the smallest number, and it is minus. If it is minus, it's good for us, right? And after that, make everything 0. Yeah, this would be the smallest number, right? So will it be minus 2 to the power 31? Not exactly. Let's store this number first, right? And see what is the real value. So 2's complement, if you want to store this number, we need to do 2's complement of this, right? Because whenever, just remember, whenever storing negative number, the computer does 2's complement. Please remember this point which I wrote here. This is important. This is important, right? Please remember that. So let's do the 2's complement of this. Let me write it in written. Let's do the 2's complement of this. What will be the 2's complement? It will, this will be 0, and after that everything will be 1 1 1 1, right? And then I will be adding plus 1, because that's what 2's complement means, right? What will be the value of this? 1 plus 1 basically means 0, but with carry 1. 1 plus 1, again this will be 0 with carry 1, 0 0. This will go till 0 0 0, and this will make 1. Now can you see, this is what we got in the first place, right? This is exactly what we got in the first place, right? So this is the negative number, smallest negative number which we can store, right? So got it. So this is what the point was, right? uh, Now similarly, let's learn about the left shift operator, right? And it's like, you can exactly guess right now what is this, right? uh, Let me go a little bit down. Yeah. So, 13, if it is left shifted by 1, what will be the output? Easy. You can just make first 0 0 till what? You can make it as 1 1 0 1. Now, as you know, what exactly is this value? You can just write 1 to 2 to power 3. like, right, plus 1 to 2 power 2, uh, plus 0 because there's 0, right, 2 to power 2, plus what, plus 1 to power 2 to power 1, right? Yes, that's the case. No, actually 3 2, this will be 0 and this will be 1, my bad. Yes, that's the case. This is what value is. Now if you're shifted, if you're left shifting the value, right, so this means that by 1, this means this is getting discarded and the new values are 0 0 till this will get here, right, this will get here, this will get here, this will get 0. Let me write it little bit ahead of this. So this will get here, right, this will get here, this will get here, this will get here, and we will get 0, right, we will get 0 here. So what will be the value here now? So 1 into 2 to power 4, because 1 has become, 1 has came here, right, plus 1 to power into 2 3, plus 0 into 2 to power square, right, plus 1 to 2 power 1, plus 0 to 2 power 0. This is the case. What will be the value of this? 8 plus 16 plus 2, which will be the uh, what, 8 9 10 26. So 26 will be the value, new value. If you left shift 13 by 1, this will be the new value of it, right? So this is what is. Yeah, so now you know that we will get this 26, right? So now you can also draw one conclusion for the left shift operator, right? As you saw here, right? I can just write that as well, right? You can say that if a number, or just hold on, if there's number x, right? If there's number x which is left shift by k number, right? You can say that that x has been multiplied. Wait. You can say that that x has been multiplied by 2 to power k, right? Let me write this in correct. So this is what the conclusion of left shift operator is, right? So whenever a number is, left shift by k, it basically means that it is getting multiplied by 2 to power k. Here you can see here that, right, that if 13 into 2 to power, basically you're getting multiplied this 2 to power k, right? How many shifts? 1, right? So 2 into 1 2 is multiplying, getting multiplied like 2 to power 4, right? So that's how, that's what the case is. 13 twos are 26, right? 13 twos are 26, so we got 26 here, right? So that's the case. Now let's learn about one more operator, which is negation operator, which I think you might now basically guess what exactly that is, right? Which is uh, negation operator, which is denoted by tilde, uh, tilde, right? So what exactly this does is that, let's say we, it basically flips, it flips. So there are two ways, right? First it will basically flip, it will flip the numbers, and then it will check, it will check if it is negative. If the number is negative, right, if the number is negative, then it will do the 2's complement for storing purposes, and if it is not, then it will do nothing, it will just stop right there, right? So that's what negation operator is. We will see with one example, right? Let's say that we take let's say we have some bits here, right? So 0 0 0 da, 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 and you have 0 1 0 1, right? So let's say you need to negate this, you need to, this is 5, right? Let's say you need to negate 5, so you will first make this as binary, then you will flip. By flipping, what I mean is that you are toggling every bit here. So 1 1 1, right? And please remember, this is the first bit, so first it is positive, now it has become negative, right? We'll see about that. So this will become 1 0 1 0, right? This is what number is. Now you have two ways, right? You need to check if the number is negative or not. It is negative because it has 1. so it is negative. It has been negative, so we won't take this way, we will take this way. It is negative, so we'll do the 2's complement. 2's complement, how you will do 2's complement? It's easy. We will first do the 1's complement, which will be 0 0 0. This will, again we'll get that same number, right? We'll do the uh, 1's complement, and then we'll just add 1, right? 1 plus 1 0 with 1 carry, 1 1 0, and this will just give us 0 0 0. Got it? And it is uh, and this has been retained. This one will stay here, right? This one will stay here basically, right? Because we are adding one. This get one will get here, right? So uh, 1101, and this will give us -6, right? So basically you can say that 5 is stored when 5 is negated. This is giving us -6. And now how will we retain this -6 back? You can just do the reverse thing. Basically, if we do, let's say now let us get back that +5, right? Again I will do one that operation, right? So let's say that we need to negate -6 right now, right? So here first we will write the -6, but first we need to store it, right? So first we will just write the +6, and then we will do the 2's complement, because we need to store the -6 and then negate. We'll then negate, right? How will we do the negation? Sorry, the 2's complement. Easy. We'll first make this 1's complement and then just add 1 here, which will give us what? 0 1 0. This will give us 0 0, and this will stay as 1, right? This will stay as 1, and this is how we will store -6. Now we are doing the negation of -6, right? Because first we need to store and then we will negate, right? Now we are doing the negation. So again 0 1 1, this will 1 0 1, right? And since this is not, basically if it is not positive, it is not positive, negative, right? Sorry, it is not negative, so we will not take this way, we'll take this way, and this will be, will do nothing. This will be how the number will be stored. And if calculating this will get +5, we'll get back the +5 basically. So yeah, so we went with +5 to -6, and then again we got the 5. This is what the proof was, right? And yeah, so this is what my point was. Got it? Now uh, you can also make one note that whenever you are doing operation, the negation, you can convert it to 2's complement basically, which we did. Like 2's complement we are storing, we need to make it as 2's complement then store, right? Now we'll see some questions where we will be using bit manipulation to solve them in a better way, right? So starting with one question. So now we will see some small tricks and tips so that you can use bit manipulation for solving a lot of different questions. So let's say first question would be this easy one: swap two numbers. Right. So now you all be will be like, yeah, we know we can just easily do that using the third variable and all, right? Like, let me just write that as well, so that if you don't know, let us, so let's say that we are given a is equal to 5 and b is equal to 6, right? Now you can just basically make a third variable, right, which will be equal to a. So temp has 5, right? And if you do a is equal to b, so b will have 5, right? But then you can just make this as temp. So basically by using third variable, like we can't again switch to b to a, right? Because this holds the value, so we can using a third variable to switch the value, right? So here in this step only we reversed and we got, and we can just be later on we can just convert, I mean sorry, we can just print out these numbers, right? But how you can do this without using this third variable, and this really common question. And even if in the interview, if the interviewer asks you this, he or she won't be happy if you do this with the third variable. He or she will always be like without using third variable, right? How you can do this without using third variable, right? So this is where bit manipulation will come here, right? Bit manipulation here. So one thing you need to recap, one operation which you learned, which was what? XOR operation. right? XOR operation basically meant that if the number of ones are even, then the value would be what? 0. And if it is odd, the number of ones in it are odd, then the value will be 1. So using this, there's one rule. I mean, there's one observation which has been made, and if you remember this, it will be beneficial for you, right, for the longer run, right? So don't question right now how we thought of this for now, but just remember that we saw XOR operation, that even numbers will give you 0 and odd numbers will give you 1. So we were like, okay, uh, if the numbers are same, if two numbers are same, and if it is given XOR operation, that those number will give us 0, right? That's the fact, right? Okay, let's say 5 5 5 I have done, right? So 0 1 0 1, right? Again 0 1 0 1, I am doing XOR operation. You can see right now here only, see that if the number of ones are even, it will give you 0. If the numbers, this is 0, if the number is even, give you 0 0. So what have you observed here? If the numbers are same, there will be same number of ones, there will be same number of ones as like even numbers will be there, and your always your output will be 0, right? So you can make a note here, which is really important, which is very important, that it that the if two numbers are XOR, they will always they will always always give you 0, right? This is the thumb rule, this you need to remember, right? You have seen, like you have seen how it is 0, right? So from now onwards, just remember that if two numbers are XOR, if you XOR two numbers, they will always give you 0, right? That you know now, right? Now let's see how we can use that in swapping two numbers, right? So so here, okay, I will just write that, right? Let's say that A, we are given A, we can do first A XOR B. This will give me some number, right? So now I can do B. I can have B, and this will have B value, basically A. This if I do again B XOR B, right? So this A will have this value, right? So this means that this I can write this. I can easily write this, right? Which will give me what? If you XOR A, A and B, you will get some value. If you XOR B and B, you will get 0, right? So you'll basically get A, right? You'll get A because there's only one operation right here, right? And if you do again A XOR B, right? So now now if you see, this B will have A value, right? So can I write A, and this will give us B, right? So this will give me what? This will give, and but this B will have the value of A, because from here this will have this value. So if you do A cross A, 0. If you do A, then it just B is left, right? So can't you see, you just you just basically swapped, you just made B as A, and you made A as B. This is how the swapping works with the bit manipulation. Got it? So yeah, just see this. I just did A XOR B, and then I just did that again. Right, you can see the internal working, that this will give me A because of the earlier operation, right? And then again I can do A is equal to A XOR B. This will give me B. So basically I swapped this using XOR operation, right? Because XOR operation, one operation is giving the output 0, so I can just swap that using this rule, right? So this is what the you can just code it out right now, right? So now let's jump to this second question, right, which is check if the ith bit is set or not. This is also one of the popular question you will find on the lead code as well, right? So this is the question basically. If you want me to explain this, I will do, right? So I can write, let's say I am given n is equal to 13, right? And I is equal to 2. I need to check. So first, how do you write 13? You write 13 as sorry, 1011. This is how you write 13, right? So what I can do here is that oh sorry, this is not how we write it. 1101, right? Now I can also write 0 1 to index of these, right? Now I need to basically check. I need to return if the ith bit, if the second bit, which means this bit, this bit is set or not. Basically set means 1, right? If this bit is 1 or 0, I need to check, right? So there are two ways basically. You can use two ways. There are two ways to solve this. Two ways using either left operation, I mean right shift, or left shift, right? So uh, I need to make you, like, really visualize this question, right? So just follow me up from here, right? Let's say we have 1101, right? And if I do, and I have I as 2, right? So basically I need to go to, okay, wait. So basically I need to target this second bit. I need to target second bit. I know my I is 2, right? I need to target here. How can I go here? How can I manipulate here to basically check if this bit is set or not? Can't I do one? Can't I shift one as left shift to 2? How, like, if I do this, what will I get? First it will be 1, then it will be 1 0, and then it will be 1 0 0, right? Basically, if I do 1 left shift 2, this will be my answer, 1 0 0 100 basically, right? And if I do this operation, right, if I use this 1 shifted to 2 with this one, right, can I do and to just check if, like, if I do and here, I will get 0 0, and if I do here and operator, I will get 1, and this will be 0, 0, so on, 0. So can you see right now, like, uh see, like, I did the same operation. I used and. So why not or? I used and because it depends on number of ones you have. If it was 0, if this was 0, this would have given me 0. If this is 1, let's see, like, if this was 1, like, it is 1, right? I need to check if this is 1 or not. Please see the question, if the ith bit is set or not, right? I need to check if this is 1 or not. That's why I'm using and operator with 1, so that if I get 1, you can just say that, okay, if I do and operation here in this particular bit, and if I get 1, then yeah, I know it is set. And if it was 0, in some case, if it was 0 and I did and with 0, what will I get? 0, which means that this bit is 0, right? That's why I did and to reach to this bit, what did I do? I just shifted it to 2. And why 2? Because we need to go to second bit. So in conclusion, code, can't I just write directly that if n is given, my answer would be AND operation of n with 1 shifted to how many places, whatever places I is given, right? If this is not equal to 0, it is, like, if n is not equal, it is set, like that bit is set, else it is not set. Got it? Just for your revision, what did I do? First, I saw that I have this one. I need to check the ith bit. Please, if you have to go to some particular bit in the question, please think of shift operation. You can also do this with right operation, right? You can also do this with right operation. That will be your homework, right? That will be your homework. I mean, just to basically get you the feeling, right operation, do with right operation, um, right shift actually, not do with right shift. Fine. So if you do AND operation, now if I saw, okay, I can make one. If I need to go to particular, I can just make shift one to two places, right? I will go to that, and then after that, I need to check if this is one or zero, basically, right? Hence, I'm using AND. That's the case. Only that. So you need to do two things here. You need to first go to that particular I bit using the shift operator, and then decide which operation to use according to the question. Got the feeling? Right. If you still are confused, please watch this again, and you will. I'm pretty sure you will understand that. And please, after getting this, do the same with the right shift operation. Fine. It's very easy. It's really direct. Right. And yeah. So with the AND operation also, the logic would be very similar. Very similar it would be. Right. And for more homework, you can also do these two questions. Basically, you can set. I will just write that. For more homework, you can do two questions more. Set the ith bit. Basically, you need to make that bit right, and you can also do the clear the ith bit. These two questions also you need to do, and I will just give you one preface of that. Let's say in the set operation, right? Okay. So in the set operation, let's say 10. Um, let's say 1101, right? And you need to go to second bit, right? 01, you can go to second bit. So you need to set the ith bit. Set basically, okay, let's say that this is 0. Set basically means that you need to make the 0 to 1, right? So if you need to set the second bit first, how you will go to second bit? You will use simple operators, left shift, right shift, whatever you want. And then for making it 1, basically set means make 0 to 1. Now how you can make 0 to 1? Can you do AND operation with this? If you do AND operation with 1, what you will get? 0, right? But what if you do AND operation? What if you do OR operation? What if you do OR operation? You will get 1. So basically here it's just the same thing. You need to do OR operation here. That's all. Easy, right? And for the similar clear the bit, again I'm just explaining the homework only, but it's fine. This is the first time, right? Now if you need to clear the ith bit, what is clear the ith bit? It means making 1 to 0. Now let's say we have this 0 1 2. You need to basically clear this bit first. How you'll go to that? Easy. You can just make this go to the right operation. You can perform the left shift operation, right? Now how you can clear this bit? What you can do to clear this bit? You can basically AND with 0. You can, instead of making this, you can just AND with 0 and you'll get the 0, right? Easy. Is it easy, right? So that's what the point is. So please code these questions out, right? And we will see of one more question. Now we will see. Now we will see how we can toggle the ith bit. Again, it's really I mean, if you sit and think about this question, you will get that most probably, right? Still, let's say n is equal to 13 again, and I am given 1101, right? So let's say I need to toggle the basically I need to toggle to whatever. Toggle means if there's 1, you have to make it 0. If there's 0, you need to make it 1. Basically reverse that particular bit. If I is equal to 2, you need to reverse this. So basically you will need to return this, which is given as 9. You need to basically return this, right? How you can toggle this? And even if let's say n is given as let's say 13 only, and I is given 1, how you can toggle this? I is given 1, which means you need to target this. So 1 1 1 1, you will get 15. So this is what toggling means. Toggle that particular bit. How you can toggle that bit? How you can do that? Let's see. So again here, let's say I have 1 1 0 1, right? And I am given I is equal to 2. Now again you need to go to the second bit. Again you need to go to the second bit. 0 1. You need to go to here. What you will do to go to here? You can easily shift 1 till I. I'm basically 2. You can just make it shift to 2. What you will get? 1 0 0 0. This is what you will get. Easy, right? Like even if you want to go any bit, you can just shift, use shifting, right? Now basically you need to toggle them. Right now toggling means that one rule again you need to remember. Even means 0, odd means 1, right? If these question comes, if these types of question comes, just open, think of every operation you know. You can think of and. Can you use and? You can use and. This will make 1 basically, so there's no need of using and, right? Can you use or? This will also, or will also make it 1, so it won't toggle particular, right? You need to make it 0. Basically you need to make this bit as 0. What you can do? You can make XOR operation. See, even means 0. So you can say, oh, there's even number of ones. I can make it 0 using XOR operation. That's how you get. That's how you think of the solutions. Right. So if you do this XOR operation of 1 0, this is odd number. So this will give you 1. This will give you 0. This will give you 0. This will give you 1. Hence, basically, what you did, you toggled this bit to 0. Got it? This is what you want. This is what you had to do. Right? Easy. So you just simple XOR operation, and you can just make a note of it that if you basically need to toggle, you can use XOR operation. Right? Just that. Now, one important question, really interesting question, I would say that like all those questions were very um basically very direct, right? Not much of thinking was required, but this question is really good. Removing last set bit. This is the question. Removing last set bit. Now, what exactly is last set bit? It basically means that wait. It basically this the last set bit basically means that rightmost bit. Rightmost bit. Right. So rightmost bit you need to rightmost bit which is 1 basically. Rightmost bit which is 1, because we are asked for one set bit, right, which means 1. So let's also take one example so that you understand this question. Right. Uh yeah. So let's say that n is equal to 12. N is equal to 12. You need to make this remove last set bit. So what how 12 is represented in binary like this, right? Now what is the last, I mean rightmost bit which is 1? This rightmost bit which is 1, not this, because this is the like before this only this is coming. So this is the rightmost bit. You need to remove last set bit. Basically you need to make this as 1 0 0 0. You need to make this operation, right? Let's say we have rightmost. Let's do more questions. 1 1, I mean more examples. 1 1 0 1. What will the rightmost set bit? This one, right? Because from right this is the last. So 1 1 0 0, you need to make this one like this, right? Now let's say we have one more example. 1000, let's say. What is the rightmost bit, set bit? This, right? Because all are these are zeros, so you need to return 0 0 0 basically. Got it? This is the question. How you will do this? How you will do this? Here, there's one very interesting observation which has been made by people, right? So, uh, so again, hang a little and listen to me for now. So let's say n is equal to 16. We will be taking these three examples, and n is equal to, and these questions like see, some questions are not like you need to figure it out from scratch. Some questions have these patterns, like everything I'm telling right now, this is all pattern like XOR. If like you can't think of let's say that you don't know anything about XOR operations and a bit manipulation, right? You can't basically come up with that thing, that XOR operation, like in an interview basically. You can't, at that moment you can't come like up with that solution, that XORing two operations, two numbers, will give you zero. Like obviously you can basically just by figuring out some examples and all, and if you do that it's really great, but again that will just waste your time, right? And the interviewer's time. So hence there's some things which you need to basically learn, like you need to remember some observations which has been done already by the people, right? And that's how you practice. Got it? So let's say n is equal to 16. How is 16 represented in binary? uh Easy. It is like 1 0 0 4 zeros, right? And how is 40? I will just write everything. 40 is basically represented like this. Again, just hold on, I will explain that. And 84 is represented as this, like this, right? Now n is equal to 16. Fine. We will start with here. What if I, like, what if I make this as n minus 1, which will be 15? What will be the bit representation of this 15? 15, how it is represented? It is represented as 0 1 1 1 1. This is how 15 is represented. Again, let's do for n is equal to 40, which is n minus 1, which is what? 39. You know how 39 is represented? It is represented like this: 1 0 0 1 1 1, right? Again, please see the pattern. If you are able to see the pattern right now, it's really great, right? If n is equal to 84, I am doing one subtraction, which is 83. You know how 83 is represented? See, 1 0 1 0 0 1 1. Can you see some pattern here? If you think for a while, can you see a small pattern here, which is finding, which is just like just in front of you? So what is the rightmost bit of 16? This, right? What is the rightmost bit of this 40? This. What is the rightmost bit of 84? This. Fine. Now if you are subtracting minus 1 from the number, this rightmost bit is getting converted to 0, and every bit after that is converted to 1. You can see that, right? What is the rightmost bit? This one, right? If you subtract 1, this is getting converted to 0, right? And everything after that is converting to 1. Again, if you see this, got converted to 0, and everything after that 0 0 converts to 1. So this is the pattern which people found out, that okay, if you subtract minus 1 from the number and you convert that to binary, you are seeing this pattern, right? And you know why this is happening? It's really, it's all about maths here, right? It's again, I can explain this phenomena to you. See, 16 is 2 to power 4, right? That's fine. 15 will be 8 plus 4 plus 2 plus 1. And how you represent this? 2 to power 0, 2 to power 1, 2 to power 2, 2 to power 3. And here, can you say that this was into 1 plus 2 to power, after that everything was 0, right? So 2 to power 3 into 0, 2 to power 2 into 0, plus 2 to power 1, and yeah, so on, right? So you can see that if you subtracted minus 1, basically the thing which was like the binary digits which were like 1 0 0 0 0 got just converted, like everything after that got converted to 1 1 1 1, as this became 0, like as 2 to power 4 removed, right? So 2 to power 3 came in power, 2 to power 2 came in power, 2 to power 1 came in power. You can see this pattern here, right? That's why this is happening. This is the reason this is happening, right? Same reason. Again, I can do this for 34 as well. Let's see. I mean, sorry, 39. Let's see 40. How is 40 represented? 2 to power 5 and 2 to power 3, right? 32 plus 32 32 plus 8 basically, right? How is 39 represented here? You can say 32, which will 32 plus 4 plus 2 plus 1. You saw this pattern, 2 to power plus 2 to power 0. Got it? So 32 basically 2 to power 5, as 2 to power 3 got removed, 2 to power 2, 2 to power 1, 2 to power 0 came in power. This is what is happening. So this is the pattern here, right here. Right, so the rightmost, after the rightmost, everything is becoming 1 because of this maths which I just explained to you. Right, so can't I just, like, so now the final solution for this problem, like setting the checking, what was the problem? Removing the last set bit, yeah, sorry. Removing the last bit. So I can just say the code or the solution basically. So can't I say that n and operation with n minus 1 will give me the required answer? How? Let's see. Let's say 40. Let's take the example of 40, right? Bigger number, right? How is 40 represented? 101, 1, 2, 3. How is 39 represented? It is 1, 0, 0, and everything else after that will become 1, right? If you do AND operation, basically this is 40, this is 39. If you do AND operation, what will you get here? 0, 0, 0. This 0, 1, right? This will become 0. So basically this is becoming, you're removing the last bit. Right, you're removing the last bit, you're checking the last bit as 0, so this got removed. Removing the last set bit, it got removed here. Just by adding. Again, if you see and, if you see removing the last set bit, if you want to remove the 1, please think of AND operation. Right, so that was one point. So this is really important observation for you all. Got it? Now, one more question, which is also a good question, basically, which is, yeah, and from here only you will get more tips and tricks for competitive level. Got it? So please stay with me. So check if number is a power of 2. This is really important question, right? You can do this with the brute force method again, right? You can do this with brute force method or anything you want. So basically, let's discuss the use. Discuss the cases like if n is equal to 16, return true because it's a power. It's the power of 4, right? If n is equal to 13, it's not a power. So just return false. If n is equal to 32, return true because it is power of 5. You need to do this. So you can basically do the brute force method of dividing it, right, by 2 and all, right? But again you can do one more things. Basically you can observe one thing, right? You can observe one thing. How is 16 represented? 1, 0, 0, 0, right? uh you can say that, let me just not use this operation, right? So let's say that we have, let's say that we have this number. I can have one operation, I can have one conclusion here, like if an set bits will give me an odd set bits, so this will give me false basically, and this will give me true, right? Because if you can see on other forms, right, that like whenever even set, like odd number of set bits are there basically, like in this case there are three ones, right? In this case there are three ones, so odd number of, so this will majorly give me false here, right? And yeah, for that, for the same thing, so I can just have this thing that if and of n minus 1 gives me 0, then true, else false. How? Let's take one example here just for your reference again. Right. So 1101, which is 13, and 12 is 1100, which is 12. Again, there's one pattern here that there's, see, like even bits 12, which is divisible, and basically you can see that even set, which means it's divisible by 2, and this it's not because you can see 13 has 3, right? So if you do AND operation here, if you do AND operation, you can get what you'll get: 0 0 1 1. You'll get this, right? You'll get this one. So this can just give you, like, if that again, if you see, this has two numbers, right? I mean two set bits. So basically if that particular set bit, the last one, right, the last one is 0, then it is true, else it is false, right? Even one more observation you can say, that if I will just write that in cases of odd numbers, the last bit is always set. There's one good note for you all, really good note for you. Even like, let's say, even this question, in this question only, 13, 13 has the last set bit as 1, and the 12, which is even number, has 0. And this is the very good logic here, I mean easy logic here, that 2 to power 0, the last bit is 2 to power 1, 2 to power 2. So basically these are the factors of 2, right? So 2 to power 4 plus 2, which will give me 6, right? And if there's odd number, it will just, if you just add plus 1 to any even number, it will become odd, right? That's why the last set bit number, if it is 1, then it is basically the odd number, right? So that's one observation for you again, right? So one more question we will do, right? This will give you more of basically tricks, right? So count the number of set bits. That's right, you need to count the number of set bits here, right? We'll see now. So counting the number of set bits, before, like, we can first discuss the brute force method for this. Right, I will just write that for your reference. So int function, let's say one function which I'm giving as int n. Right. So uh, I can have one count variable. Wait, I can have one count variable as 0. Right, I can just define one count variable as 0. And while, I can have while n is greater than 1. Yeah, that condition. So run a loop. So if n is divisible by 1, basically, sorry, if it is odd, basically, yeah, then count plus 1 is equal to 1. What I'm doing here is that, let's say that I'm just going to the bits, right? And if the, basically, if the last number, if the last digit of that, like, let's say I just told you that if the last set bit is 1, right, if the last set bit is 1, um, make it count. It is basically odd one, right? So we will be using that as well. But if the, basically, if you are uh, traversing across the bits, if you found there's one, increase that, and then shorten that, uh, basically that number, right? Because you need to go to jump, you need to go to next one. And if n is equal to 1, right, then also count plus 1 is equal to 1. That is also one case. After that, just return the count, and you're done with this. This is the simple code of counting the number of set bits. Basically, first condition, if the n is equal to 1, you are increasing that, uh, right? If the number is odd, basically this means that the number is odd one. If the number is odd here, you are increasing the count variable, right? And yeah, and as you are, basically, you are just seeing, you're just In every odd number, the last one would be the set bit, right? If it is odd, so it will have one, and then you will just increase the count variable, and after, and when I'm doing n is equal to n by 2, basically I'm cutting this number, and I'm just considering this one, and then after that again I will cut this, and last one will be left, right? So that's the basic brute force method or basic code right now, right? uh, so yeah, as we know that the last bit of odd number will be set basically, right? So even if you, so that's one conclusion of it, right? In the case of odd number, the last bit is always set. You can also add that here, right? That is one of the conclusions that we are using right now, right? uh, Also, I can just do one operation basically, right? Let's say that we are given as 0 1 1 0, right? And I'm just doing the AND operation with 1. What will this give? This will give 0, this will give 1 1 0, this will give, this will be the case. And since this is the last is 0, this will be the even number, right? Basically I just did the AND operation just to check if it is even or odd, right? So ANDing with 1, and let's say we have 1 1 0 1, and I did the AND operation with 1 here. So 1 1 will give me what? It will give me 1 0 0 and 0. So this here, this signifies that this is the odd number. Basically the last bit is 1, so this is odd number. So for checking, I will write one more conclusion here. For checking if a number is odd or not, I we can do AND operation with 1. So this is a really important, like even the competitive coder uses this thing, right? So basically what they do is that in our last question as well, like we were using the while operation, right? While n is greater than 1. In this case, I can write I can write this count is and operation. Basically this means that if the operation, like if this is odd number, then increase the count. Also, if you want to shift, basically if you want to make it smaller, you can just AND with 1. This is what you can do, the change here, right? Let me also write that. So this means that you are basically making AND as this, and this means checking check checking if num is odd, right? If n is odd, then you are just increasing the count variable here, right? So also, so basically this is what they do in the competitive coders do. Instead of writing n is equal to n by 2, they prefer doing this the shift operation, because bit shift, basically bit operations faster are quite faster. That's why they choose to do bit operations, right? And hence also for odd check they do this, like if n is this, right? So this is what for odd check they do, and for n by 2 you can use you can shift n with 1. So this is what majorly the computer coders do. uh, so yeah, so please keep a note of this. Right. So also one more operation, I forgot one more operation. Like you usually used to do this low plus high by 2, right? So by 2. So instead of this, what they use is that they just do low plus high, right shift by 1. Yes. Because you can see by for n by 2, if you shift it, basically if you are dividing by 2, if you are making a number, let's say if you are making some number, 4 digit number as 3 digit number, you can just shift it by 1, right? So instead of dividing by 2, Like even in my previous lectures, you might have seen that when doing the permutations, right? So we used to first consider these and then we used to break it. So how to break it? We were using n by 2, right? So instead of this, you can just use the shift right shift operation, right? So it is quite faster. Hence they use it. Fine. So yeah, so that's the case. And yeah, now we need to basically make this count the set bit number more optimized, right? So let's take one example for this. Let's take n is equal to 84, right? Which is denoted by 1 0 1 0 1 0 0, and n is equal to 83. How will this be? Easy. Just make the rightmost bit as 0 and make after all those bits make it 1 1 1. If you do AND operation, what you will get? You will get all these zeros. This will give you 1, this will give you 0, this will give you 1. Basically you will get this, right? uh, and so basically what we are doing here, we are making, so see, so we need to calculate the number of set bits here. So after doing one operation, after doing this, after doing n with n minus 1, one set bit got removed. Yes, right. Like, see, compare these. First, compare this. Sorry, compare this with this. You see, one set bit got removed. So this count as one operation plus CNT. If you do the same operation, if you take this same operation, again you do this with AND operation. Let's say, okay, let me show this 1 0 0 0 0 uh, 0. Let's say that you subtracted 1. What you will get? 1 0 0 1 1 1 1. You'll, if you do that, you'll get that. And if you AND that with 1 0 1, sorry, 1 0 0 1 1 1 1. If you AND operation, if you do the AND operation, again you will get the last bit removed, 1 0 0 0 0 0 0. Again you got that. Basically again, now compare again, compare this with this. You removed the last bit, so again plus CNT. Here you got plus CNT, one operation. Basically here the count was got 1, here the count got 1, from 1 to 2 it got, and now again you do this same operation. Basically if you do the same operation, you AND it with minus 1, basically. So 1 0 0 0 0 0 0. If you minus 1 this, you will get this 0 1 1 1 1 1 1, right? And if you do again the AND operation, you will basically make everything 0. So now again compare this with this. You made this as 0, so again plus count will happen, which will make 2 as 3. Now you can see number of set bits here were 1 2 3. As you removed one by one bits, you got the count as 3. So this is what, how the bit operation, using bit operation you can write the code. So I'll just quickly write that code. Let's say you have count as 0, right? And you can say while n is not equal to 0, n is equal to n and with n minus 1, right? And as you do this operation, keep increasing the count and then just return count. That's all. Simple. This is the this is the easiest code now. You can see, like, instead of doing all this operation of this, you can just easily write how to count this bits here in this way. Got it? So that's the case. And yeah, one last question I want to do. One last question. After that, I will give you, or let me just give you this as homework because we have crossed uh,
the duration now. So one homework for you is basically like minimize bit flips to convert a number. I will just explain the question to you. Basically, uh, let's say we have one number as 10. We want to make it to 7. How you can make it? So 10 is represented as this, and 7 is represented as 0, 1, 1, 1. Right? How you can make this? How many minimum bit flips you need to do? How many bit flips you need to flip this, right? So that you get one. You don't need to flip this because it's already one. You need to flip this. So basically you need two minimum bit flips, right? So what you can do, how you can basically see which all bits are different, right? You need to check here what all bits are different which you need to flip. So it's really easy. I just told you the answer right now. What all bits are different here? How you can see? Just use XOR operation. If you need to compare, like, let's see, like if you will get XOR operation as this, right? Just see that. So the number of set bits, basically number of set bits will be equal to the answer of this question, right? This also you need to set, right? Sorry. So number of set bits here will be the number of answer of the question, basically. Right, if you do the XOR operation, it will give you the number of bits which are different, and hence set bits here will be the answer. So this is how you'll do this question, and please code the solution yourself and let me know. And if you have any doubts, one more homework I want to give you. One more homework will be the if you just search the power set, basically print all subset. If you find difficulty in doing this question, please let me know in the comment section. I will make the video for that as well. And yeah, so please practice a lot. This was really good topic, and I will see you in next video. Thank you.